Physicians often want to look at patients' chromosomes to be able to diagnose a chromosomal abnormality. Any cell that contains a nucleus can be collected for examination. The cell is killed during the metaphase phase of mitosis, and it is stained so that the chromosomes are visible under a microscope. All of the homologous pairs of chromosomes are collected and arranged by size and staining pattern. The sex chromosomes can be seen. This individual is male, with an X and a Y. Any extra or missing chromosomes are also visible in the karyotype. Most humans have 23 pairs of chromosomes. Each sperm cell brings 23, and each egg cell provides the other 23. If an error called a non-disjunction occurs during the production of sperm or eggs, the offspring could have the wrong number of chromosomes. Non-disjunctions occur during anaphase of meiosis. The homologous chromosomes in meiosis 1 and the sister chromatids in meiosis 2 are supposed to separate during anaphase. If the chromosomes do not separate properly, one or more of the resulting gametes will have the wrong number of chromosomes. A cell that has one extra chromosome will result in an offspring with a trisomy, 3 of that chromosome. A gamete that has one too few chromosomes will result in an offspring with a monosomy, only 1 of that chromosome. Most changes in chromosome number cannot be tolerated by humans. These zygotes do not develop and miscarry. There are a handful of chromosomal abnormalities that can be carried to birth and some that can live in the entire normal life expectancy. The most common chromosomal disorder of the autosomes is trisomy 21, or Down syndrome. People with Down syndrome have a distinct physical appearance. They are short, have an eyelid fold, a flat face, stubby fingers, a round head, and a palm crease. There is some degree of mental impairment ranging from mild to severe. This karyotype shows an individual with an extra 21 chromosome and resulting in Down syndrome. Trisomy 13, Patau syndrome, and trisomy 18, Edwards syndrome, can also occur, but most individuals die in the first few months of life. All other autosomal changes don't survive to birth. There are several chromosomal abnormalities of the sex chromosomes and are tolerated better than those of autosomes. Individuals only need one X chromosome, since all males only have one. Extra X chromosomes can be condensed into Barr bodies and become inactive. Poly-X syndrome occurs when female individuals have one or more extra X chromosomes. The extra X chromosomes are turned into Barr bodies, and there are no distinctive phenotypes of this syndrome. Klinefelter syndrome happens when male individuals have an extra X chromosome. This extra X chromosome also becomes a Barr body and is inactivated. Often the testes and prostate gland are underdeveloped, resulting in sterility, and the individual lacks facial hair. They may be slow to learn but have no other major health abnormalities. Some find testosterone therapy to be helpful, but most do not need medical treatment. Jacob syndrome occurs when a male individual has an extra Y chromosome. These individuals tend to be tall, have acne, and experience speech and reading difficulties. They are fertile and have no difference in behavioral development than unaffected males. Turner syndrome is the only viable monosomy in humans, having only one X chromosome. The physical features associated with Turner syndrome are short stature, a broad chest, and folds of skin on the back of the neck. The ovaries and uterine tubes are underdeveloped, and individuals do not go through puberty or menstruate, and are thus infertile. There is no intellectual disability, and individuals can lead a normal life with hormone supplements.